Hello there, and welcome to Dresden. I'm standing here in front of the Bosch semiconductor plant. This is one of the most advanced plants in the world for making chips for cars. I'm Nicole Scott, and I'm here to take you on a virtual journey, a journey into the future, a future built by Bosch. If you have a VR cardboard headset kicking around, you'll be able to join me on an immersive 360 tour. Now, if you don't have one, don't worry about it. You'll be able to click around this virtual world on your desktop or tablet, and you'll be able to spin around and see everything. Bosch is building the future, a future built on tiny chips. This is Bosch's new wafer fab, which makes semiconductors. The site we're standing on is as big as 14 soccer fields. The factory and office space covers 7,200 square meters. It's been under construction since mid-2018. And now at last, the doors are opening to Bosch's brand spanking new wafer fab. Okay, Superman, your superpowers are extraterrestrial, but my superpowers come from this world. They're terrestrial and invincible. Don't believe me? Thanks to me, your smartphone takes crystal clear shots of all your adventures. Ever since you got a smartwatch, I've been keeping an eye on your fitness. While you're sitting here, you can come to the rescue anywhere in the world in real time thanks to augmented reality. And in your home, I make sure the temperature is perfect for superheroes, and I can take care of all your other creature comforts as well. When it comes to flying, well, I have to say that Ingenuity, the Mars helicopter, flies a heck of a lot straighter than you do. And if you decide to go by car, no problem. I'll always be with you as your guardian angel and smart sidekick. What's the secret of my superpowers? The power of semiconductors, the building blocks of the future. The Bosch wafer fab is made up of 3 buildings that all have the latest technology. It's been built from the ground up with connectivity in mind. It's connected, it's automated, it uses AI, digital twins, and is 5G ready. It is practically unimaginable. Life without the internet and smartphones. Smart chips have long since changed nearly every sphere of our lives, including mobility. But how did this come about? As early as the 1950s, Bosch was researching extensively into semiconductor technology. Soon after that, the company began mass-producing its first semiconductor elements. In 1970, Bosch mass-produced the world's first integrated circuit for cars at its plant in Reutlingen, Germany. This was a cornerstone for the company's phenomenal success in automotive electronics. This, by the way, is what a Bosch integrated circuit looked like in 1975. It's featured in the Jetronic gasoline injection system. A few years later, in 1978, a digital integrated circuit featured in a production vehicle for the first time. This is when Bosch premiered the ABS anti-lock braking system in a Mercedes-Benz S-Class. Sensors have since become smaller, more reliable, and less power-hungry. One example of this at Bosch is micromechanical sensors, or MEMS sensors. At Bosch, the first MEMS sensors were mass-produced in 1995. Up to today, Bosch has made more than 15 billion of them. Since 2006, it's been making these tiny chips for consumer electronics as well. The new Bosch microchips made of silicon carbide are now helping electromobility make a great leap forward. In power electronics, they ensure that 50% less energy is lost in the form of heat. Thanks to increasing electrification, connectivity, and automation, demand for chips in vehicles is expected to rise further over the next few years. As a key technology for the Internet of Things, Bosch semiconductors have applications that extend far beyond the world of vehicles. Up to now, the sole site for manufacturing these building blocks of the future has been in Reutlingen, near Stuttgart. It's now being joined by a new wafer fab in Dresden. The result is a fully connected smart factory made possible by the combination of the Internet of Things and artificial intelligence. This is the wave of the future, built by Bosch. Semiconductors have been around for quite a while, and they have a great future ahead of them. Whether it's Industry 4.0, Smart City, or Smart Home, chips are really making our lives safer, easier, and more secure, which is true to the Bosch ideal of invented for life. If you take a look right over there, you'll see a car that's chock full of semiconductors. You'll find them everywhere. From the rain sensors to the seatbelt tensors, inside the airbags, driver assist. The average car today has about 500 euros worth of semiconductors inside. And according to experts, that number is set to rise, thanks to things like the infotainment system, driver assistance systems, and the electrification of the powertrain. And a lot of these chips are made right here in Dresden. Digitalization is changing the way we communicate, live, and work. It's also changing the way we get from A to B. The cities we drive through will be smart. Driving will be automated for the greatest possible convenience and safety. It'll also be connected for seamless infotainment pleasure. And electrified for mobility that is sustainable. The mobility of the future will be safer, more efficient, and more exciting. All thanks to advanced chips, the building blocks of the future. In the competitive world of tech, semiconductors for vehicles is the ultimate challenge. They have to face strong vibrations and extreme temperatures, from well below zero to way over 100 degrees Celsius. Developing and manufacturing these semiconductors requires a lot of expertise. And that is what we're going to see here today. We're going to head into the heart of Bosch's wafer fab. But they are not going to let me in dressed like this. So let's head to the changing room. Here we are in the changing room. It's where I get to put on an absolutely crazy outfit. If you're wondering why I have to do that, it's because wafers and semiconductors are manufactured in a clean room environment. The ambient air contains about 100,000 particles per cubic foot. In there's one particle weighing half a microgram per cubic foot. That's the equivalent of a single cherry pit in all of Lake Constance here in Germany. If you're wondering how we achieve that, it's through a special cleaning infiltration system. Now it's time to gear up. Let's get in there. Welcome to the heart of wafer production. Take a look around you. Up, down, and all around, there is a lot to see. This is where semiconductors are made. This is the clean room. This is where the magic happens, where humble sand is turned into the building blocks of the future. The process of manufacturing semiconductor chips starts with a disk of ultra-pure silicon, known as a wafer. It looks a little bit like a record, doesn't it? The bigger the wafer's diameter, the more chips can be made in each manufacturing cycle. This is one of the reasons why Bosch will be producing 300mm wafers for the first time in this new factory. But how do we go from wafer to tiny microchips? Well, it's not fast or easy. It takes several hundred manufacturing steps that can last as long as 14 weeks. But don't worry, we won't be doing it in real time. Humble sand. This is what the building blocks of the future are made of. But making them is a long process comprising a great many steps. First, the silicon dioxide in the sand has to be converted into pure silicon. After that, it is cut into wafer-thin discs. In Dresden, these raw wafers are 300mm in diameter and less than a millimeter thick. In our clean room, up to 35,000 chips are then made from each of these discs. In numerous process stages, the wafers are given their characteristic surface structure. After coating with a photoresist layer, the wafer surface is exposed, developed, and etched. This results in the desired conductor structure. Such structures are hundreds of times finer than a human hair. Dopants are then implanted in the material to increase the electrical connectivity of parts of the semiconductor. In subsequent phases, this and other process steps are repeated until the entire layout of the chip has been deposited on the wafer. This involves heating the wafer to more than 1100 degrees Celsius, in some cases up to 27 times. Up to 200 measurements are done, and up to 26 exposures. All in all, this can mean as many as 700 processing steps and 14 weeks processing time. Once this is completed, the microchip is assembled from as many as 30 such layers, like a mini skyscraper. Each layer has its own function. Interconnecting them makes the microchip highly complex. Semiconductor chips, the building blocks of our future. The Bosch wafer fab in Dresden is the company's first AIoT factory. AIoT is the combination of AI, artificial intelligence, and IoT, the Internet of Things. Put them together and you get AIoT. So far, so good. But what does this mean for the plant here in Dresden? AIoT is being used to make the Dresden semiconductor fab a connected smart factory. This will be the basis for the manufacturing process that is data-driven and continuously improving. But before we get too far along, it all starts with the wafers. A fully automated feeder system runs along the ceilings, taking them to and from the individual fabrication stations at exactly the right time. It's a bit like the way red blood cells carry oxygen around our bodies. Smart computer systems guide the wafers as they make their way through the manufacturing process, which is several hundred steps and lasts up to 14 weeks. Artificial intelligence plays a special role here. The highly automated production facilities analyze the data in order to optimize their processes. This is how Bosch enhances the quality of the chips. The factory generates 500 pages of production data per second. Printed out, that's more than 42 million pages a day, weighing 22 metric tons. The only way of handling this is with AI and complete connectivity. On top of that, the new semiconductor fab will be 5G ready right from the start. This means that it will be possible to exchange huge volumes of data in real time, completely wirelessly. The Bosch plant in Dresden has even more high-tech cards up its sleeve. Augmented reality, for example. Thanks to smart glasses and tablets, users will be able to see digital content superimposed on the real environment. Let me give you an example. This allows Bosch to display energy data from the semiconductor fab in a virtual model of the building, and then they're able to optimize energy use. Smart glasses are also able to help when modernizing and expanding a factory. They'll show where the pipes and cables are on the wall and can be used for remote maintenance. Associates in the wafer fab can also quickly contact customer service engineers around the world. The Dresden wafer fab is like a complex organism. Night and day, it has to be stocked. And it basically needs a second factory to do that. It's called the subfab, and we're standing in that right now. It's basically beneath the factory floor. If you take a look around, there is so much cabling lying beneath the wafer fabrication floor. It keeps the operation supplied with special gases, air, and electricity. This place is full of pipes, cables, and hoses. The electrical cabling alone is 380 kilometers long. That's all the way from Dresden to Berlin and back. Incredible. And there's another highlight I'd like to show you. There are 2 Dresden wafer fabs, one in the real world and one in the digital. You can check it out right over here. Down to the tiniest detail, the whole building is mirrored in the 3D model. You could say that the twin is the factory's virtual double. So what this means is all the ventilation, all the piping, all of this exists in the virtual world. And that's so that they can optimize and improve the factory. And all of these things will happen over time as the factory needs to grow. And so they can do that all here in 3D modeling with the digital twin. Here in Dresden, Bosch is making the building blocks of the future. The future of mobility, the future of the Internet of Things. The chips that Bosch makes here will have to meet ever higher standards of quality and performance. But the building we're standing in is ready to rise to that occasion. It's sustainable, connected, and smart. Welcome to the future, a future built by Bosch.